question A, the free body diagram of the object is this. So there are three forces acting on the balls. The first one is W, which is M times G. This force is going downwards. Second is the frictional force. The direction of this force is opposite to the motion of the ball. The third one is the normal force. Normal force is perpendicular to the motion of the ball. Okay, so the second question is we want to find the velocity at point B. So we will apply the equation for principle of work and energy. So we will use 1/2 times mass times VA squared plus mgh equal to 1/2 times m times VB squared. So firstly, since the initial velocity is 0, so half times 0.3, which is the mass, times 0, and we will get 0 plus mgh, which is 0.3 times 9.81 times 2.5, the height, equal to half times 0.3 times VB squared. And finally, we will get VB equal to 7 meter per second. For the third question, we will find D. So we use the horizontal equation of motion. So we will have XC equal to XB plus VBX times TBC. So basically, the thing that we want to find is the XC, the distance, equals to XB, which is 0, plus velocity for X component, 7 times 4/5, times TBC, which is the time. So we will obtain this equation, D equal to 5.6 TBC, which is the unknown TBC that we want to find. Y component, we will have this equation, YC equal to YB plus VBY times TBC plus half times AY times TBC squared. So Y at point C is -1, Y at point B is 0, plus V for Y component, -7 times 3/5 times TBC plus half times -9.81, which is the AY, times TBC squared. And then we will obtain this equation. -1 equals to -4.2 TBC minus half times 9.81 times TBC. After that, we will arrange the equation into this form, and then we will solve the unknown TBC using the quadratic equation technique, and we will get two different answers, one positive and one the other negative. So we will take the positive answer and we will replace the unknown TBC from the previous equation, D equals to 5.6 TBC, and we will replace the TBC with the positive answer, and we will get the final answer, D equals to 1.087. The question asks us to find VC, so we will use this equation again. So 1/2 times mass 0.3 times VB, which is 7, which is we obtained from the previous question, 7 squared, plus mgh, m 0.3 times 9.81 times 1, equal to half times 0.3 times VC squared. So we will get VC equal to 8.28 meter per second.
Question 2. A. Calculate the velocity of the object just after it rebounds from the ground. The object forced from A to B due to the gravity. Then the object forced force to the point C with 7 meter per second velocity that I name it as VBX. The object rebounds to the next point due to the hitting impact and create another velocity which is VC that I will be find in this question. Firstly, we have to find the vertical equation of motion. VCY1 square equal to V1Y square plus 2A multiplied by SCY minus SPY. SCY is the initial height. SPY is the final height. Y negative 1 because the object moves opposite the direction of our assumption. VCY1 square equal to 0 plus 2 multiplied by negative 9.81 multiplied by 0 minus negative 1. So the answer for the VCY1 is negative 4.4294 meter per second. Second, we have to find coefficient of the restitution. That the formula is E equal to VG2 minus VCY2 divided by VCY1 minus VG1. The E has been given from the question. 0.7 equal to 0 for the VG2 minus 2 minus for VCY2 that we have to find divided by negative 4.4294 for the VC1Y minus 0 for VG1. So the final answer for the VCY2 3.1006 meter per second. Next, using the linear momentum equation, M multiplied by VBX equal to M multiplied by VCX. VBX we can find it is on the diagram that 7 meter per second. So the VCX equal to 7 meter per second. Finally, we can find the VC2. VC2 can be in vector form equal to 7.0036I from the VCX and plus 3.1006J from the VCY2, and then we got the answer VC2 equal to 7.6593 meter per second. Next, question 2b. Compute the maximum height to which the object rises after the first bounce. Using the vertical equation of motion, negative 2y square equal to VCY square plus 2a multiplied by S2y minus XCY. S2y is the h that we have to find. SCY is 0. VCY can get the previous question. So the final answer is h equal to 0.49 meter.